Hello. What I want to show you today is StormSensor's dynamic flow system. StormSensor produces sensor devices that are embedded within municipalities' stormwater and sewage water systems. These devices measure things like rate of flow of water, temperature, depth of water at a certain point, and volume of water moving through a stormwater system. This technology is built on Uber's DeckGL combined with D3JS and Visually IO, and it's all web-enabled through WebGL. So any modern browser can use this system. What we're looking at here is a map of Jersey City and certain elements within the Jersey City stormwater system. We have elements like sewer outflows with associated data that's picked up by sensors. We also have sensors embedded in line within a sewer, as well as things like regulators and screening facilities. These are all different elements that this municipality would like to monitor within their stormwater system. In addition to these elements, we can dynamically toggle certain elements. So we can look at a combined sewer outflow and see what sewers are connected to that outflow that are being highlighted here. We can show different flow rates within these systems. These are color-coded based off volume. They can also be color-coded via temperature. We can show flooding that might be occurring within a region within the system. And all of this is very dynamic. We're able to zoom in and out and rotate and look at this map from a bunch of different angles. We also want to be able to see alerts that might have been triggered by a sensor when certain parameters have gone over a threshold. And so we can take a look in alert panel. For these alerts, we can click on them and see associated devices. So we can see here. And we also have the ability to show a timeline. So what we see at the top here is a graph of rainfall over a period of time. We can adjust the window of time we're looking at, and as we adjust this, you'll see it will calculate the total rainfall for that period. Within this, if we expand this graph here, we can also animate this time series and see in real time or in historical time, but in a live feedback mode, how the storm event might have affected these sewers. So we can see water flowing through the system here. I zoom in. You can see how water flows. We're also watching alerts being toggled as this playback is occurring. So as this loops through the beginning of the playback, we see these different alerts that have occurred at different times. We have the ability to show flooding as it was occurring within that system. You can see as this is moving through, this flooded area is expanding. We get a sense of where the storm might have been impacting the system. We can also show the effects of tides encroaching on lower areas. And as this moves through the system and the tide gets higher, these bars get bigger. The idea behind this graphic display is to take all the data that's being captured for a municipality and being able to display it in a way that's intuitive and allows for analysis of all this different information coming in, and to be able to see the patterns and relationships that might be occurring within a stormwater system. This is just a small subset. A fully enabled system would cover all of these city blocks with many more devices and sewers. We plan on being able to, in the future, show topographical information or elevation information, so we can see low versus highline areas, see the gravity flow within systems, and also have a more granular insight into precipitation rates. So for instance, where rain might be falling heavier in one area than another area, we'll be able to graphically display that on the screen as well. Thank you so much.